right? So the class today, we're going to walk through this tutorial, but that's like one part of it. I actually spent way too long in the morning class going back through this tutorial, and it's online, so I don't want to waste. I don't want to spend that much time on it. Like, I mean, I want to do more time on this. So maybe all I needed was like 20 more minutes. So I'm going to start. I think we're going to do the Nervy Dome first, but we're going to go a little quicker through it because it this video is available after, and as is that tutorial. The only thing is of course, just like we did last week, that tutorial is a little older, and the way that the lists are approached and a couple of things are just a little different. It's like 7 years old, so things have changed a little, but not much. I mean, just like tiny things. So we're just going to walk through it and kind of see like also how to approach it with a more, I guess, like parametric view in mind, so that the whole thing is kind of attached to one slider again. You know, like we went over last week, you can have like multiple control sliders, or you can try to relate them all using like math, right? We had multiplication and things like that, so, but some sort of relationship that's attached to the original slider that can then parametricize or make it more make it a little more parametric than you know, just having to control this one, control this one, control this one. It can get kind of overwhelming if you have too many controls. So we'll talk through that. The assignment for this week, so the goal of the assignment that we're talking about, and the reason we're going to do all these studies, is that so you've done, now your first week was folded plate tessellations. So, you know, rectilinear planes almost, right? Or some sort of rectilinear planes, like flat planes. No complex curvature, maybe in the form, but the rest of it should have been pretty simple in your folded plates. And then last week we went into complex curvature, where you had to develop some sort of shell structure and tessellate that. And this next week, what we're going to study is tessellation on a grid, or of a grid. Depending on what approach you take, you can do one or the other or both. You can be inception of grids if you really want, and geometry and whatever else. You can, you know, take everything we've been learning and apply it all to one. Or you can just, you know, find a grid that you like and just model it too. That's fine. So this is the reading that's available to you. Again, it's available also online at at Professor Peluso's website. It's also available in our class drive, under assignments, parametric grid structures, and did I upload it? I didn't upload it yet. Okay, I'm sorry. It will be available to you. That's my bad. But anyway, so this reading you can use as your reference, and in it you'll find a couple of different ways to approach grids and frames and stuff like that. So you can see here we have some nice examples of different tessellations. We'll be doing a diagrid version, okay, that you can see here, right? It's more line based, and then we'll be doing more of like this horizontal tessellation ish. It's more like a space frame, so which can be vertical or horizontal, it doesn't matter. So you can see it has simple versions where if you want to, you can model crown halls, rectilinear frame and grid. Then you can also take that simple, you know, very like I don't know, it's a very simple like XY grid, right? And you can take it and kind of give it a little bit of a zigzag, or you can start to create openings and form the grid around that. But the idea is that you're using Grasshopper to control those openings. I would say that for this next week, you're probably going to end up looking as cool as this stuff is. We're we're actually going to be introducing more of, there we go, if I keep zooming down or scrolling down, more of this stuff where you're going to be learning how to create a grid on a surface. Okay, these diagrid-like things. And these are just exterior, this is just exterior wall, right? With a different grid attached to it, or arrayed across it. So you can find one of these that you really want to try to recreate. The strategy that we are giving you is more of a point and line based. So you'd probably want to get the form first, and then, well, you'd want to figure out how to get the form from your points and lines, and then create the diagrid about that. So I'll show you what I mean by that, of course, but you're going to want a surface and then divide the surface. But that surface is going to have to be made up of some sort of structure. So you're going to need to figure out the form and then diagrid around the form. Okay, so what we're going to be doing today is more like, I guess more like this, where we're talking about how to create this diagrid-like pattern about a surface. That's the Nervy script. And then the next part of the script, or the next thing we'll do that I want to get into is creating this space frame. So we'll figure out how to do that similarly, where we'll have a surface that's controlling the form of this, right? Like this one has, no, this one's just a flat plane, but then we get a folded plane, like folded plate structure with a grid, like as its actual structure. And then you get this kind of parabolic structure where, again, the space frame is what's going to be supporting it. That's where the forces are going through all of the space frame members. But that, the form itself this is actually coming from, in Grasshopper, it's going to be coming from a surface that is parabolic. Same thing with this. This would be coming from some sort of, it's reading a surface and it's following along that. Okay. All right, so this is here for you to get like ideas, I guess, it's more just as a guide. Again, if you want to use it as a jumping off point, so you want to just copy one of these and then see what that script does, that's also perfectly fine. Whatever you want to do that gets you excited and interested, that's all I want you to do, okay? Again, it's 3 different parametric iterations and include the Grasshopper definition. All right. So I think that's enough of that. You know what, I probably should say one more reminder, since we are here and there's 1, 2, 3 more weeks and then it's supposed to be midterm. If you're, I've been getting a couple of notes of like of remoteness, like you've gone fully remote or you would prefer to be remote for the midterm. Can you send me, if you haven't said anything, can you please send me a message? And then I think probably I'll compile a list, and next week we'll talk through how many people are going to be remote, and then we'll figure out if the midterm, which I think is probably going to be split, so we'll figure out a way to do the folks who want to be in person, and then the folks who want to be remote. Just how that works time-wise, that's what we have to figure out. So I do need a running list of folks. So far I have, for this class, I have Ashton, Colin, and Samra as remote students, fully remote. Is there anyone else that has not let me know that you would like to just have me mark right now? Or is that Clark? Okay. All right, themed, okay. And yeah, and you might have, if you did send me a message and I don't have you marked, I'm sorry. If I have gotten a couple of them, so I also just wanted to check. Okay, so right? So that's 5 folks. All right. So yeah, I guess if if things change, if you want to go remote for your presentation, just send me a message. I'd say probably by week 5, so not next week, but the following week. That's a good deadline. And then I can start to rearrange just how we're going to do that. Okay, cool. Okay, so I am presenting. Great, that means I can go into RhinoSpace and we can get started. All right. So I'm going to turn off my grid because it's really loud. And we can start on our nervy dome. So I'm going to kind of show you what the dome is supposed to, or is going to look like. Okay, this is the goal of our script. It's a wireframe of the nervy dome that is in Italy, and I think Rome, Italy, and it was like 1957 or something. It was built. It it just always amazes me that this was built without grasshopper, because to me it looks definitely like something I would grasshop and not try to figure out on paper. But we think very differently, I think, than people used to. So yeah, so it's a good study for grasshopper just because of the diagrid like nature, and also the symmetry of it, right? Like this thing is perfectly symmetrical. Oh, that's not it. This thing's perfectly symmetrical about the entirety of the dome. So it's a nice exercise for us to work with lists. That's what we'll be doing today, is working with lists and getting a little more familiar with what lists are and how to control them and how to make them work for us. So you can see here then there are kind of 2 different parts to the structure. There's the top part that's more of the diagrid, and then there's the bottom part that is the supporting structure. So all of these columns are kind of, they're pushing those forces back in, right, into the dome that is pushing out. So so the way we're going to approach it, since we're just doing a 2D study, right, we're just doing wireframe. There's no 3-dimensional members that we're adding to this. Of course, if you want to do that, you're welcome to. But I figured this is enough for us to learn from today. We're going to look at how to divide this up into parts that are manageable for us. Okay, and so the first part is going to be this diagrid that we're going to make. Okay, and I think this is probably the part where we'll actually repeat a similar exercise up here, a little different way, but we'll use the same sort of surface division is what it is. That's the strategy that we're going to use, is surface division, to get these quadrants that make up these series of lines. You're actually looking at a series of straight segments, but it appears you're looking at curved ones. So yeah, we'll figure out how to do that. First, we need to create a series of circles. Okay, so this is, if I go in my top view, look at this here. Right, obviously it's all about the center and it's all about a circle. So what we need to do is we need to create a series of circles that are going to form our diagrid. Okay, there's a bottom circle, a top circle, and a central circle that is going to make up our arc. Okay, if we look at this in profile, this appears to be an arc, and that's the surface that we're going to make. Okay, so we're actually going to use this. We're going to create this surface and then use that the subdivisions of that to create that diagrid. Okay, so let's start with the circles. Okay, the first circle that we need to make is using, if we type double click, we type in circle, we want to choose this first one, this one with the orange box. It says defined by base plane and radius. Okay, if we zoom in here, you can see that it says plane and radius. One other thing to note is that I have my draw full names on. I've noticed I've been doing that the last couple weeks. I didn't even think about it. Typically, I will model like this, where I have my display and I have it set to I have my draw full names off, and that's just a preference thing. It doesn't matter either way. The helpful part of the draw full names, especially for us, is that you can see as I'm talking what it is. You can read it on the screen. If I've said it too quickly, you can at least check it out and make sure that that is indeed what you have. Versus sometimes you'll watch a tutorial and they'll have it like this. Well, if you don't know the capsule, you have to like search your capsules, and it makes it kind of tricky to find it. So I'm just going to keep my display at draw full names. Okay. All right, so the first circle that we're going to draw here is this large one. Okay, that's going to be our circle 1. And so the radius of that is going to be 30. The plane is going to be the default XY plane. If we wanted to model this, not in an XY plane, turn off. There we go. Just finding it really distracting to have it on for it now. I don't know why. Okay, so if I wanted to change the plane of this, I could do construct plane. And I would define a different origin by defining a different point. Okay, so I could bring a point down into space, and I could select that as my new origin. Set one point as origin. Oop, there we go. Oh, I accidentally clicked on this. I didn't mean to do that. That's the way it goes. There we go. Okay. So you can see I can set my plane, and I could have it attached to a physical object in Rhino space so that it could... it's not working. Why not? Because I'm trying to explain it. That's why. I tell you. Set one point. Okay. There we go. Okay, there we go. Cry minutely. Okay, so the point being that you could reference a point, which is this guy, in your Rhino space, and you could then adjust this, or ideally adjust this. I think I have 2 points set up. There, I do. Okay. You can ideally adjust this plane in Rhino space by just moving that point. Okay. So that's a nice trick to know if you're modeling, for instance, something about the XY space in one area. You could create a new plane and model it about this new plane in another area in space and have them both live. And that way I keep showing you model around 0, 0, 0. Well, if you're modeling more than one, then that's not really helpful. So so it's a nice thing to know how to do, but I'm just going to stay in the 0, 0 plane here. Okay, we have our first circle, and we're actually going to copy and paste that, not once, but twice. Okay, and then each of these circles, this is going to be 24. You can double click and enter that number. Okay, same here, you can double click and enter 12. Okay, so you have 30 for circle 1, 24 for circle 2, and 12 for circle 3. Okay. So if we look in our right-hand view, and I select all of these, notice all of those are on the 0, 0 plane. We haven't moved any of them into Z space like we want, right? The red ones are the circles that I've already drawn. That's where we want them to be. So what we need to do is we need to pull down a move, double click, type in move, we need a move capsule that moves in the Z direction, right? In the Z direction. So I'm going to double click, type in Z, enter my motion vector, have my geometry, enter that into the move. Okay, shift this up a little bit. All right, and then the discussion is how much do we move, right? So this is set to, if we move to the right, we can actually see how many spaces because I have my grid set up so that you can see it's at every, 1 foot, our major line. So I have it actually set to, this is the circle. So that's set to default of 1. If we look at our factor, it says 1, but we want it to move to 4. So we'll double click, we'll enter 4. Okay. And now you can see it's shifted up to 4. That is for this, this circle 2. That should be at that height at circle 4. Our circle 3, which is this guy, he should be at twice the height. Okay, twice the height of this middle circle. Okay. So to get that, we could just copy and paste this and say we want this to be 8, and that would be sufficient. But I think a better idea is to copy and paste the move in the Z and then use a multiplication capsule so that we have parametric control, right? Multiplication. Because that way, that relationship will always stay true. As we adjust our 4 value, this will always be twice the height, right? This one will always be twice the height of our middle circle. So I'm going to take a panel. I'm going to enter 2, okay. Right, and that way it will always be twice the height, okay. So if I take a look, I'm going to turn off these guys so we're not distracted by my old script. If we take a look at adjusting this 4 height, okay, this should be, oh, I didn't enter it. That would help. Okay, helps to actually input your output. Okay, so notice it jumped up to the second one. Then we also need to input our circle 3 geometry into our move capsule. And now those things are looking more appropriate, right? So we should have circle 1 set at the bottom, 0, 0, or at 0 for the z-axis. Circle 2 will be our next one, and that should be set at the 4 height. So our move geometry is moved up 4. And then our circle 3, which is our small inner circle, that should move up twice the height of whatever our middle circle's at. And then in our right-hand view, we can see how that translates as I adjust this. These guys should always keep that relationship. Awesome, that's what we want. Okay, so so that's to get the circles, and the circles are going to let's turn off these 2. We don't need them anymore. Circle 2 and circle 3. We want the moved circles. We don't want the base circles. So I'm just going to turn those off. Right? We have to do a select, right-click canvas, preview off. Okay. So I want just these, and what I need to do, like I need what I said before. I said we need to create a surface about this. About these circles. The way to do that is to actually create an arc, a 3-point arc, using this as our center point for the arc, and then these both as our start and end. And then using that arc, we can sweep it about the rail of the circles. Okay, so let's make the 3-point arc. 3-point arc first. So we'll need we need these points, right? Point A, B, C. Well, to get those, notice we have curves, right? We need the point. So if we enter end point, and we enter our geometry, you'll see that it creates both a start and end point at the same point. Obviously, it's a circle, so that makes sense. So if I copy and paste this, and I do that for each one of these circles, I can then extract the points that I need for my arc. Okay. So I have we'll do start point as point A, that's the base. Middle point will be the middle circle start, and the end point will be our inner circle start. And that's how we'll get our 3-point arc that we're then going to use as our profile for our sweep command. Okay, so I don't know if you're familiar with the sweep command in Rhino. If you are, that's great. If you're not, that's fine. It's the same concept, so it just helps to understand what we're doing. So if you type in sweep 1, here, sweep 1, what sweep will do is it will take a section, or otherwise known as a profile, which is what we've created here, and it will use a rail to sweep that about an axis, okay? Or sweep it about a curve, I should say. And the curve is the rail. So, for instance, here we have this arc. The arc is going to be our section. Our rail is going to be, we're going to say curve 1. Okay, so I'm going to go back to the beginning and pull my curve, my circle, okay, and use that as a rail. It should just appear like that. So it should immediately create for you a surface that is a sweep about that rail. And once you do that, then we are pretty much done with this first setup, and we can group these things. Okay, so I'm going to scribble, and I'll call this probably my main dome line work or something, curve work. I want it's my construction grid really to set up the stuff I actually want. So I'm going to group all this and just group it together. It's probably a better way to do it, and you can finesse it as you want, but for now, that's I think a good stopping point for the first grouping. Okay, because the next point then is the part of deconstructing a surface and using the grid that we deconstruct it as the base of our grid for, you know, the space frame or for the diagrid or for whatever structure we're going to make from that division. So, so double click and we'll do deconstruct. Okay, we're going to deconstruct BREP. Deconstruct BREP. We take our BREP and input it into that. Oh, wait, what am I doing? Sorry, I'm getting ahead of myself. We would want deconstruct BREP, but first we have to actually divide the surface. Okay, so 1 second. First we have to use isotrim, and we have to use divide domain to the second, okay? Then it's deconstruct BREP, so sorry, I'm getting ahead of myself. I'm on repeat. Okay, so first we need isotrim and divide domain in order to control the parameters we get from the deconstruct BREP. Okay, right now if we deconstructed it, all we'd get is one surface. But what this is going to do is it's going to break down our one surface into multiple surfaces. So this isotrim, for instance, the other name for it is subsurface. I think in the older Grasshopper it used to be subsurf, and isotrim was like another name for it, and now it's become just isotrim. It's no longer subsurf. But what it does for us is it creates a number of subsurfaces, so it kind of was a good name. So what we're going to do is we're actually going to get all those subsurfaces using the domain divisions that we're going to get from this capsule. Okay, the divide domain to the squared. Those segments are they're going to be what are the controls of those divisions. So if I pull my BREP down and I put it into the domain as well, you'll see that the default U and V count are both set to 10. And if we look at that, we can see it's true over here that there's 10 different quadrants about the surface, and there's going to be 10 different quadrants in this direction as well. So it creates it in both the U and the V. So to understand, I think, what exactly is happening. So this is our divider, right? It makes sense, divide domain. And then these are the actual surfaces that are each made up from that division. I'm just going to bring down a list item so you can see what exactly is happening. Okay. So you can see here I pulled down a list item. And what it's done for us is it's picked out the first item on this list of surfaces. Okay, and I'm going to bring my panel down too so you can see. So you can see here that right now this is showing us that there is a list of, what does it say, 100 surfaces, right, 10 by 10. There are 100 surfaces in this list, and what this list item is doing is it is giving us one of those surfaces, which is this one. Okay. If we look at our top view, you can see that it is right at the x-axis, and it is the first on the, remember how we put the 3-point arc in, and this was 0, this was the start point, end point, start point, middle point, end point. Well, this is now our kind of start point for the list that was created from that subdivision. So, so if we look at what was happening before from this original BREP surface, you'll see that it's got a similar output, right? Because here it was only one surface. And I know it sounds like I'm beating a dead horse, but it is kind of important to understand that each of these is now its own surface. And if I now do deconstruct BREP, and I take my surfaces, my list of surfaces, not the list item, I don't want him. If I take the surfaces and I deconstruct them all, what's happening is I'm actually going to deconstruct each and every one of these surfaces. So for example, and this is just for me, I'm going to take my list item and deconstruct this one. If we look at it, you can see that it's divided it, or it's not divided, but it's deconstructed it so that I have one face, yep, one untrimmed surface, okay. I'm going to have 4 edges, right? 1, 2, 3, 4 edges, and I'll have 4 vertices, okay? 1, 2, 3, 4. And that's true for every single one of these surfaces. So this is my list of all of those surfaces, and then this is my list of just that one surface, right? So this is feeding back to me that list of data. And what I want to use is I want to use that point list to create an X on each and every surface. So an X meaning I want a line from point 0 to point 2 and from point 1 to point 3. So guess how we're going to do that? List item. I don't know if you remember from last, we are going to use it so much. List item, it's going to be our best friend. And it really does help. It makes things easier to pull from lists and use and all that stuff. We just kind of are going to use it a lot in these first couple weeks. So list item is going to pull for us the 0. So in the list of vertices, bring down my panel so you can see all of our vertices. Okay, so this vertices list is actually a list of lists. I know, it's just perfectly confusing, but it's a list of lists. So it's a list of point lists, meaning that this first list is a 0, 1, 2, 3 list of points about one surface. So if I pull this over and take a look at it, you'll see that my one list item surface has 4 points coming about that surface. If I turn on my point list and I input that there, you can see it says 0, 1, 2, 3. That is true for every single surface of these 100 surfaces, okay? So each one of these has 0, 1, 2, 3 on every single surface. So if I input my isotrim surface back into my deconstruct and I get my list of lists with my 0, 1, 2, 3 points for each and every face, then what I can do with this is I can extract those points. So if I extract every point 0, I'm going to get every single point 0 from each one of these lists. And if I go in and I zoom in and I do plus, 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 I can output my every 1 point, every 2 point, and every 3 point. So that when I want to do a line, my start to aim, okay, right, start end point. Okay, I can take my 0, right, we had said we wanted to do 0 to 2, 0 to 2. Oofta, that is getting really cluttered. Let's turn that off. Okay. Okay, better. We can do 0 to 2, and that's going to create a line from 0 to 2. And I can copy and paste this and do from 1, 2, 3. And each of those is going to create then a line on each of the faces, which then is going to appear like some sort of X across the structure. And if we go back then, if we go back to our, where's our division? There we go, our U count, our divide domain. This is where we can control the number of divisions. So I think it is 108 for the U. Yes, okay, there we go. 108 for our U, and the V gets like 6 or something like that. Okay. So you can see that what this has done is it's dividing that surface even more, and it's creating a subsurface based on those divisions. And then each of those subsurfaces is creating, there's an X being created between point 0 and 2 and point 1 and 3 on every single surface. So that if I were to turn this off, preview off, what we get then is a diagrid-like appearance, right? It looks like they look like curved members, but they're actually each a straight line segment from one point to the next. It's just a series of X's. Okay. All right, I'm going to delete my extras. And we're going to actually need that for later, so I'm going to turn that off. And then for these guys, these two lines that we made, the X's, I'm going to merge them so that they are all, I'm going to take both data streams and merge them so that I can select one capsule and I get both as my output. Okay, so that's getting a diagrid from a surface, and that can be used on any surface. It just happens to work like a curvature or a period curvature because of obviously our shape, but you can try that on any surface and you should get a diagrid or some sort of grid. Okay, so is there any question before I move on? Is it all relatively simple? Cool. Okay. Felt like I did that kind of quickly, but like I said, this is also available after class too. All right, so I'm going to group this next part and do scribble. I'm going to give it a name, probably a diagrid maker. Okay, group these things, and now we have that for later. He's going to be special, right? We're going to need him for later if we want to create, like if we want to pipe them or if we want to bake this. So I'm going to group that and give it a different color, but he's what I want to interact with. Okay. All right, that's the first part. And let me zoom out and move that. Okay. All right, so part one is diagrid. Second part is, let's take a look at our nervy derm, our nervy dome. If we look at that, this internally, there we go. You'll see that, so we have the diagrid that comes up, and then there are these straight line segments that attach to a central circle that's at pretty much the same height as where this stops. So that's how we're going to, where the diagrid stops. So that's where we're going to model it to. So we can take our circle. We can take our, so I'm holding shift, right, as I'm selecting these. We can take our move, our Z, and we can Control C, Control V, and just move those below our workspace. Okay. And we can rename this circle 4. That's going to be this inner one up here. And let's turn on, we want this circle 3. Yeah, we want to see that because that's, we're actually going to use that in our model. Okay, so circle 3 should be on, the one that we moved. Okay. We also want to turn this guy on because he's the one we're going to be dealing with. Oh, and lo and behold, our radius is still the same. So let's change our circle 4 radius to 8. Okay. But then the height is actually going to just stay with the same height. So our Z can stay plugged into this multiplied result, and our curve is now where we want it. So all we need to do is divide it, right? So in here, it's these number of points are the same as the number of points internally. So because they make up straight lines, right? So they have to be an equal number of points. Otherwise, they'd be all over. But you need a point here and a point here to attach your straight lines to. So all we need to do is to divide each of these with the same number, and then create a line in between one circle and or one string of points and the next, and we will get our straight line segments. The thing is we want to align those straight line segments with this, right? With the diagrid that's happening. Meaning we don't want another number slider, we want to steal the number slider that we have so that we get the same number of divisions, even if we were to change, say, our divide domain into fewer segments or more segments. Okay, so I'm actually going to take him out right now of my group, right? He's in my group, and we're actually going to use him a few more times. So I think I'm just going to right-click the group, remove from group, and bring him down and Control G and make him his own special group. Okay, and I'll just call him a dome divider. Okay, my dome divider. I'm going to pull him way over here. Okay, and I'm going to do that because he's going to come up a few more times in the script. Now I know that because I've done this now a couple times, and that's what I ended up doing. But as you would work through a script like this, you would probably decide eventually to make him special in some way, because he is going to end up controlling so much stuff. And by moving him off the canvas, you see you have the edge of the canvas, right? By moving him off the edge of the canvas, and by then starting to create a list of controls for you, so that you kind of have a control center that you can interact with, and you don't have to walk through the script as slowly, as clunkily. You don't have to find things, which I have seen some of your scripts now, and I can see that you're starting to get the flow, right? You're starting to get the wires and the whoo hoo hoo. So by pulling them off to the side, you can start to kind of control that. Okay, so right, our divider. So we're going to actually, and maybe it's just divider because he generally just divides all the things. Okay, so I'm going to take that number, that 108, and I'm going to bring that into the divide curves that I didn't make yet. Okay, so we need to do a divide curve. Awesome, okay, because we need to divide this curve, right? Center curve. We also need to divide this curve. So I'm going to Control C, Control V, and input this curve as well. So we have two divide curves. Okay, this is my moved circle 3 here. Okay, so that also needs dividing. I'm going to shift this down. Okay, and then the count that we're going to use is that 108. So I go back here and I input him into my count, my divide curve count. You can see those all update, right? And that makes sense because that's what we use to divide our domain. So there's going to be the same number of points as divisions on the circle. Therefore, those should align. Take this again, and we'll divide that inner circle count. Okay. And then they each have an equal number of points, right? We have the same input, so they have equal number of points, and I can create my line. Okay, start point, end point, and there are my straight line segments. Okay. All right, so that's it. We're happy with that. That should be exactly what we want. You can adjust this as you want, of course, but I think 8 is the proportion that the actual dome is. We'll do a scribble. And we'll do straight line segments. Main dome. A lot of words, but I know what it is. And I'm going to group all of these together. Control G. Okay. And then he is going to get Control G and a red color. Okay. So I'm going to turn off both of these, preview off, but I'll leave that circle on so that we can actually see him. I think it kind of helps for definition to the 2D structure, right? Okay. Now, if you haven't done it already, I would click Save your file so you have this for later, because then we're going to move on to the kind of second part of the structure. So we did this first part, the dome, the inner circle. Now we're going to do all the support stuff. So I'm going to do one more check-in before we move on, just so I don't... Okay, I missed that last step to make the final grid. What was that again? The last step to make the final grid. Is this back here? Colin? I'm just going to put that up for you. So we did deconstruct from our isotrim, we had deconstruct, and then we used that vertices list. We had a list of 0.0123. We connected point 0 and point 2 for line 1 and point 1 and 3 for line 2. I then did a merge capsule, so I brought in both of those lists so that when I select this, I select both of them at the same time. I'm not selecting multiple capsules. And in fact, I could probably also merge this guy so that he's all together, right? And you can keep using merge for that. You know, you can add on more of these inputs so that when, if you want to only select one capsule for your bake, it's a nice way of keeping all of that information together. Okay. All right, did that help? Are you good?
Quick question. What's the difference between like merge and just grouping things together by using a group capsule?
The group capsule in Rhino space or in Grasshopper, so like this.
Yeah.
So what group is? So yeah, so that's a good question. So group is it's more of an organizer for Grasshopper space, but it doesn't actually perform a function other than just spatial organization. Um, what merge does is merge is an actual live capsule um, that if we bring it down, we can take a look at what it's telling us. So you can see that it creates a it brings together all of the information into one data stream for us. Okay, so like if I were to look at what these outputs are, I'm going to actually take this guy out because it's easier to see without him. So I have I have a line here and a line here. And if I were to look at what these outputs are, okay, Control G, okay. All right, so these panels are they're so helpful. Okay, so if I look at what the information is that I'm getting a list here of lines, okay? And you can see that this list of lines and this list of lines, right, both of them are actually merged together so that it's creating a new list where these 0 line items, they stay 0 line items, right? But these 0 line items become the next line item. So it's merging the data together so that when I select it and I bake it, it's going to those are going to be uh, like I'd have to group it. Like when I select bake and I group, then they're going to be, how do I say? They'll be grouped in Rhino space, but they're going to still be separate lines, right? Because each of these is still a separate line segment. So I don't, if that's what you're asking, the difference between, because it's not joining them, it's just merging the data so that they're in the same list together.
Yeah, I see what you mean now. Okay.
Is that, okay, all right. And then I think entwine is another one. So entwine, we can take our data, okay, and if I input, right, okay, you can see here what it does is it creates 2 different lists. So if we go down, right, oh, we just about missed it. Okay. So this, it keeps these lists as separate. So entwine is going to flatten both of these and create 2 separate lists, keeping this one, they call it branches, this branch of data of lines going in the one direction, right, this guy, separate from the second one. Versus merge them together so that these lists are now a list of lists. And if I were to do list item, I would get every 0 line item. If I were to do list item for 1, I'd get every 1 line item. Versus here, it's going to be, if I get 0, if I do a list item and I do 0, I'm just going to get this first line item of each one. So I'm just going to get 1x. Okay, so it's just different data handling. And you could use, for our purposes, for the grouping of them, because we're not going to do much more with this, you can use merge or entwine. But both of them are useful right now for the collecting of data. How about that? We'll call it a collection. Okay. So I'm going to bring him in as well because he's just going to be a part of our collection. Okay. Right, save, and then, right, okay, so now we're going to go on to the second part, the support structures. So those like V columns, kind of Y columns. It is pretty though, isn't it? It's nice. Yeah, It's definitely like, I don't know how they came up with it without Grasshopper, like the perfection of it. Of course, probably flowers or something, but okay, so right, so we need the base columns. I need to check my numbers here, make sure I have them right. We have 37 at 6, 34 at 3. Yeah, okay. Okay, so the next part is we need those base columns, and that's going to be another series of circles. So what we can do is we can then take our circle, and I'm going to choose circle 3, take our Z capsule, our move capsule, and I'm going to create a new number slider, so I'm just going to ignore that one. Okay, so I'm going to Control C, Control V, and what we essentially need is to create another larger circle. Sorry, that circle said it was a radius of 37, so we'll just do that right away and get that done with. Okay, that's circle 5, circle 5, yeah, circle 4, 5, okay. So it said it had a radius of 37, so that's for our base column points. But it needs to have a Z motion in the negative axis, right? Because we modeled this originally about the zero axis of the Z plane, right? So in the Z height, this had a 0 value, which means that everything we model that supports it has to be negative, it has to go below. So we're going to bring down a negative capsule, input that. Oop, doesn't work, does it? It's because it actually needs a value. So I think that was 6 we had. So we put our 6 into our value. Now it's going to work. So notice it moved down, and we can see in my screen that it moved down 1, 2, 3, 4, 5, 6. Okay, so that's great. That's where we want it. We'll check here. All right, that looks like a good support base. All right, so we have the base structure. Now we actually need a second circle because those Y columns, they have that line that we're making. So if we look at the nervy dome, you'll see that this is the line that we're making. We need just a line segment, straight line segment. So we can use the same concept that we used for the top part of the dome, which is just to create 2 circles, divide them with the same number, and connect those points. So I'm going to just copy this whole thing, Control C, Control V, bring it down, rename my circle, circle 6. Okay, and this is actually going to be 3. And this guy was 24, I think. Is it 24? That doesn't look right. Is it 34? Ah, see what I mean? Bad memory. This is why I have to look at my script. 34. That makes sense. 34. Ah, much better. Okay. And our top view, what does that look like? Okay. Nice concentric circles. Okay. So with both of those, now we can divide those with the same number. So we'll just do divide curve again. Control C, Control V. Notice the repetition. This is yep, get used to it. Okay, so notice the default is 10. Okay. We're actually going to divide it 36 times. And we'll take that as the same input for both. Beautiful. Okay. So we have the same number of points for each circle, meaning we can now grab our line, this line, create a line between 2 points, and we can take our start point as our base and our end point as the next tier, right? And there's our support structure. Okay, and he actually becomes important again. So I'm just going to group him and pull him also to the side because I know that he's going to be reused. I'm also going to relabel him. so that he's important. Okay. But yeah, 36 is the number of divisions then for that outer circle. Okay, so he's our line here. So I'm going to just, the rest of it we don't need. I'm going to scribble and call it base columns, straight segments. Okay, and then this is just going to be grouped all together, and that's my output. Control G, right click, change color, becomes blue, or no, red. Okay, and then I can move on to the V. So, so looking at the V here, right, we have the straight line segment, and now we need to take this point and we need a new circle in between our diagrid and the base columns for our V to attach to, right? And if we look at it, we think about it a little bit more. This had 36 divisions. Now this is actually off center of that 36 division, right? So if I have the same point here and it creates a straight line. If I have the same point here, it's going to create another straight line. So I actually need to divide this next circle and find the point, the midpoint between this line and this line. Okay, right, this is the midpoint between this line and this line. And that's how I'm going to attach my base column point to my next tier point. Okay. So I'm going to draw one more circle yet again. Circle number 6, I swear it's the last one. And I'm just going to take all of this stuff, Control C, Control V, bring it down, give it circle 7. Okay. This is actually, I'm going to delete that, and I'm going to give it a new number slider with 1.5. Okay, so it moves down. Interestingly, this moves down 6. Right, that first one moved down 6. The next one moved down half that to 3, and this one moves half that to 1.5. So it's a nice, nice relationship that they're creating. Okay, and then the radius. Who do I remember? Nope. 32. Okay. 32. Let's check that that's right. We'll take a look. Okay, that appears, notice it should appear like a straight line down to the base, right? If we think about forces having to make their way from this dome all the way down to the base, it should be something like a straight line. So we have our next tier circle. Now we need to divide that. We've moved it half the distance, so we need to divide it again. Okay, divide it, and then we're going to actually take our multiplier, because we need twice as many points, right? We need to find the midpoint. Oop, multiple curves, multiplication. Okay, that's going to be the result, but the multiplication is going to be twice as many points as this 36. So I'm going to pull that 36 number over into my multiplication, and then I'm going to steal my 2 from up here, Control C, Control V, and drag him down below so that I have that ready for me. Okay. So, all right, so we'll zoom in here, we'll take a look. All right, cool. So I have my point set up, and I have these available to me, but now I have to figure out how to attach this point to these points. There are a couple of ways that we can do it. I am going to show you one way, which is less list heavy, I guess. But there are multiple ways to achieve the same goal. Okay, there's the polar array way where we're going to create one shape and then polar array it about the central axis. There's also another way where you could control a list, and we can set up the list so that um, it produces all of them at the same time. Rather than arraying the same geometry, it actually just makes the geometry. So let's do the polar array way first, because we also want to polar array the next tier as well. So we want them both to be arrayed about the central point. So we have this V, but we also are going to need this double V. So we'll create both of those and then array them all together. Okay. So, all right, so we have our divide curve. So if we look down here, and I am going to bring out a list item. Okay, I'm going to take my divide curve list, and we'll see what that does, right? So this was a list of points about that circle, right? So with this one starting at 0. That means this point is the last one on the list, and this is the next point on the list. The output we're getting from our list item is going to be the first point, right? That point 0. So to get this point and get this point, so that we can create straight line segments, we can zoom in to our list item, and we can press the plus on the bottom, and then we can use the top plus to get the last item on the list. Okay, -1 will always give you the last item on the list. And if you didn't want to use your outputs here, you could also input a -1 for the index, and that will also give you the last item. Okay, sometimes it's useful. Sometimes you want that. Like right now, we want to use for the -1 to get this guy. So we have let's see, we have this item, we have this line item. We want this line item. So I think we actually need another list item. Told you you're going to get to love them or hate them. And we need to snag it from this circle 6 that we divided, right? For the straight columns. So we need to get those points, and we need to grab that list item for the 0 line item on that list. And now we can take both of these and create lines in between this point and those 2 points. So line, we'll create a line between 2 points. We'll do this is the start point, and then this guy is the end point. We're just going to enter both of these. So we'll hold shift and enter both negative and +1 to get our V. Okay, great. So now that we have that unit, we're going to go ahead and we're going to also create, before we polar array, we're going to create these line segments, these 4 line segments that we saw. Okay, so we have this guy, and then we're going to take these guys and we use them as a unit to polar array about the axis. So I'm going to, I'm going to use him as, because we'll need this point as our starting point. So we're going to need this +1 as our point to connect to these 4 points. So I'm going to bring a point capsule and just pull him out so that he's available to me. And I'll rename him like a V point or something like that, V endpoint. So that was a container I brought down. Okay, I double clicked, I typed in point, and I got a point container. And he doesn't really do anything, right? He just contains the data. So he just pulls him out of that script for me to use later. And then I can do the scribble and the renaming. So I'm going to call this my V column. And here's move over, and we'll just group all of this, right? Because I'm going to actually use him. And then this guy is Control G, and he is a color red. Okay. All right, so then the next thing is to, we need to find these 4 points about this circle 1, right? This was our original circle that we drew. So I'm going to also use a container for that circle because it's way up here, and it would be really sloppy to bring him down and start working in this space. So I'm going to enter, double click and enter curve and get a curve container. Okay, and then this is going to accept my curve, and I'm going to rename that circle 1. Okay, and now he's the same exact thing. If I adjust him, if I adjust this, he also adjusts. Okay. All right, so I'm also going to right click on this receiver, right, this wire that's coming in, and I'm going to choose that wire display to hidden, so that when I bring him down here, the only way I see that cluttery wire is to select him. I could do the same thing with this V endpoint too, actually. And now we have 2 receivers, and it just makes it so much cleaner, right? Especially if I want to start over on this left-hand edge, I don't have these guys coming down. Okay. All right, so we have our circle and we have our endpoint. Now I need to divide this circle. Okay, so I'll divide it, divide curve, and I need to divide it 108 times. So it's a good thing we have our 108 divider capsule. So I'll bring that down and I'll put that into my count, right? Because that's however many we divided our original surface by, so it should be the same. And then I need to list item again, right? Because I have my line of points, and now I just need 1, 2, 3, 4. So I'm going to list item, point list. That gives me my 0, but I need 0, 1, 2, 3. So I'm going to zoom in, and I'm going to get plus, 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 0, 1, 2, 3, get all 4 points. Then I have my V endpoint, and now I can do, I can do line, create a line between 2 points. Okay, so I actually want him as my start point, so I'm going to move him up there. I want him as my start point, my V endpoint is my start, and then all of these will get a hold shift as I input each of them, and watch, you can see as they populate my screen. Okay. And there we go. We have our V unit and we have our double V unit. So I'm just going to type in a scribble and call this my double V. And he's going to get a grouping. And then this one's also going to get a grouping and a color because he's a special unit that I want to interact with. Okay, so the last thing we need to do then is we need to array this about the central axis. And we need to array this unit and, if I hold shift, this unit, right? The V and the double V to get that perfect array of symmetry. So double click, polar array, and my geometry is going to be, I'm going to actually enter this one first. Not that it matters, but I'm going to enter that, hold shift, and enter my next line. Notice their default is set to 10, so we need a certain count, and our count is going to be this 36. So we will input 36 for our count, and voila, we have our polar array that aligns perfectly with 36 support columns. Okay, and if we look in perspective, you can see how that translates to a form. Okay, so the things to note, of course, there's always things to note. Okay, so if I select this and I select, well, actually, if I look over at my sliders and I see that I have my 36, if I look at my top view, it's easier to see. Remember we had our two magic sliders. One controlled the bottom, right? So that live updates and all of our geometry is referenced off of this original slider. But notice the mid part isn't moving. The first part we did, the base dome. But if I go up to here and I adjust these, this part will update separately of its base. So what we need to do is we need to get the top main dome and the support structure to speak to one another so that they are at least fully parametric in terms of repetition. And because we had originally set this to 108, 108 is a multiple of 36. We need a multiple of 3. So I'm going to do a multiplication capsule and a panel, and we'll do 3 as our panel. Okay. Do 3 as our multiplier. Okay. And then A is going to be this, what was 36? Okay. So A is going to be here. So that the result then, if we hover over the result, we can see our one locally defined value will be 108. Awesome, that's what we want. But now we have to replace, in order to get that to update within our script, we have to go through and we have to replace every single one of these wires that we had input as 108. So you can select that and you can see where all of those wires go, and then drag and drop this new result into those inputs. So I'm just going to pull my multiplication result way over here, and sure enough, remember our diagrid maker, the U count needs to have that revised input. I'm holding nothing down, I'm just replacing the wire. So don't hold shift or anything because you'll get multiple inputs. Just replace that wire. Okay. The next two are these divide curves, which were the central circle, right? Both of those got 108. So we're going to replace both of them with a new count of that multiplier. And then the last one was this bottom one that we just did, which was the double V, right? The divide curve at the base. He got 108. So I'm going to pull this multiplier down here and input that into the divide curve. Okay, and now our lonely little 108 can be deleted, and the new divider, so I'm just going to say divider control or division control, it should now all be related to each other because of our multiplier, right? And there we go. So now they will align, right? As we divide the circle, these should each get a new, they should align at least for the interior and for these exterior supports. All the points should be shared because they're sharing the same number of divisions. Okay, so I would save, and we flew through that, I think. How are you guys doing? Did that make sense? Do you have a dome on your screen? One other thing we can... Oh,
I have a question.
yeah.
Yes. So my connection kind of cut out for a few seconds there.
Oh, no.
And I was wondering if you could go back to maybe the part where you create the number slider that is named divisions, to kind of how you got to that point.
Oh, great. Yeah. Okay. So, and actually, so you should probably I think you're talking about I had the 108 thing. What I did
Yes.
was, right, so what I did was I replaced, I noticed that with the 108 and the 36 down here, my 36 was controlling my bottom portion, and the 108 was controlling the top portion. But 108 was a 3 times 36. So what I did was I brought down a multiplier, my multiplication, and I just
Mhm.
used that division control as as the multiplier, and then I input a panel for 3, so that the result was always going to be 3 times whatever my divider was, and that way the relationship will always stay the same. So, so they aren't working separately, they're working in unison together. But that meant
Okay.
that every input for 108 had to be, I had to go back through my script and find them,
Mhm.
right? So,
Okay.
okay,
Yeah,
did that help
I
or?
understand.
Okay,
Yes, it does. Thank you.
okay, cool. Right, so I think the only other thing that we'd want to do here is probably clean up our script, right? Because we have a bunch of points and everything that's happening, and a lot of things are in preview that maybe don't need to be in preview. So I would actually probably do an entwine so that each of those data branches stays separate, as we saw, and then just input them into this so that I can see that they are all staying together. And what you could do is you could also merge. You could probably do one set, right, as merged for the top, and then the bottom could be its own other thing, or you can entwine them all together. It doesn't really matter. The idea being that you have a container of the geometry and that you only have to click on one thing rather than click on each and every output and bake it. So right, so now I've entwined them all. I have 3 streams of data. But if I then select the rest of my script, right click preview off, I'm only going to see the net, I guess I'm going to say, that we've created, but I don't see any of the circles. So I would probably also go back and just zoom into my branch and add more inputs for each of those circles so that those are also visible. Okay. And so that'd be circle 1 was important, right? That guy. And then these 2 circles that we moved up here. So we had not circle 2, but circle 3 that we moved was important. This inner circle. So this guy, circle 4 that we moved up, right? And then I think, let's see if we take a look at the nervy dome. Yeah, we had the circle 1, and this guy does this, so we'd actually have to like go back and change the script a little bit more. So I think that what we have is fine for at least what our goal was, which was to play with lists and and get used to list item. Wasn't that fun? Okay. So we could bake it, or we can start to try to add geometry to each one of these outputs and then input into here. But I think for now this is a good stopping point. Okay. So I'm going to select all of this and right click and do preview off. Save my script, and then I am moving this down below, but we're going to work on the next part of class here. Okay. So it's 3:46. I'm going to take a really quick water break. You guys are welcome to as well. And then I would say we can do 3 minutes, right? Like 3:50. Because we still have like another 40 minutes of class. Okay, so I'll see you in like 3 minutes. really quick. Just like just interrupt me. It's totally fine. You know, it's the quirks of remote learning, right? Like there's certain limitations. So all right, so that was the first part of the script, which was more of the diagrid approach. The next part is going to be this kind of space frame approach, where we're going to use the similar isotrim and divide domain technique to get the subsurfaces. But then instead of using the surfaces, we're actually going to use, or even the vertices, we're going to use the edges of those surfaces to get this. You can see there's a base kind of grid here, right? It's in a rectangle. And then above it, there's actually a second rectangular grid with connecting supports in between those two grids. So they're kind of hovering over each other with the center point of each of these crosses with the crosses at the center point of each one of those rectangles. Okay, and vice versa. So we can see that here if I turn on my, okay, so if we look at this, you can see that I had some sort of form work, right? There was like a surface that I quickly modeled, and from that surface I divided it and I found the edges. I then created a second grid, right? So I have my base grid. I created a second grid using the center point of that grid, and I offset it, and then I used that center point as the base for the that offset grid. So I don't know if in plan, because this is so warpy, if you'll see it, but you can kind of see here, this is a good, you can see how there's a grid underneath, and then there's a grid over, right? And the crosshairs are set at the center point of each one of those rectangles. And then to connect them, right, for a space frame, we have our diagonal supports, and those connect from the center point to each one of those corners. So what we're going to do first is we're actually going to model the surface in Grasshopper, but we're going to reference Rhino curves to get that. Okay, so I'm going to turn this off, and I'm going to turn my reference geometry on. So I've created a new layer for my reference geometry. I have my A as my curves, and I have my B as a surface as my other option to bring in. My first one's going to be the A curves. And in your top view, just to make two curves, doesn't matter, they can be whatever curves you want, but I use the control point curve to have my grid snap and my ortho both off, and then just clicked in Rhino space so that and enter, so that I could create a curve that has, if I select it, it has these control points. I can start to move back and forth, right? I can then select that and hold Alt and drag over to create a copy. Or I could just draw another curve, right? So if I look at this in my perspective view, you can see that these are my original two curves that I had drawn. Those are kind of a little more funkier, right? Those have actual like Z coordinates. Whereas this is just at 0 because I drew it in the XY plane. So I can adjust that and make them a little more fun to play with by just selecting it and shifting these control points, you know, in space. So it has a little bit more of a body to the actual curve. Okay, because what we're going to do then is we're actually going to loft between these two curves to get the surface that creates then the space frame. Okay, so in Grasshopper, once you've created these two curves, you're going to want to double click the canvas, type in curve, and you're going to bring in a curve container. Just like we did before where we had the geometry container and all it was doing, it was just holding the geometry. This does the same, it's going to be doing the same thing. There's no input, there's no function that's happening, which is why it's container, not a capsule. And so, right, so we are just going to right click and we're going to do set multiple curves. If you do set one curve, you'll just get obviously one curve in the container versus setting multiple curves. You can, if you have them already selected, it will just know that those are the two curves you want selected. Or you can do right click if you don't have it selected in Rhinospace. Right click, set multiple curves, and then you have to click on however many curves you want to input. For us, it's just these two, but you can input as many as you need. Okay, so those are our two curves. They should show up green if you have this selected. That's how you know that they're actually in the container. And then if I select this one curve in Rhinospace, you'll see that the benefit of Grasshopper is that it just continues to reference that geometry. So I can adjust these things in Rhinospace, but my Grasshopper will it will always reference, you know, whatever is in Rhino. So it's a live update and it's kind of nice. All right, so I'm going to loft these, loft, and input my curves into my loft, and it should stretch a surface across them. Okay, if your curves are too funky, it might make a pretty weird surface, so you just kind of have to be aware of that when you're making your curves. They should be a little bit, they can be a little funky, but they shouldn't be too wild, otherwise its approximation is kind of, it doesn't really work. Okay, so we have our curves. Our surface, or sorry, we have our surface. So what we want to do is we wanted to have the same approach that we did for the Nervy Dome, where we did the isotrim and the divide surface. But this time we're going to do deconstruct with, to get the edges and not the vertices. So we can do the same capsules that we did before. We'll do isotrim, and we'll do divide domain. Okay, and if you remember, we took our surface, so our loft, and we input that into the isotrim and into the domain, and then the segments goes into the domain. Okay, and the divide domain, the default is set to 10, which is fine. We can leave it at 10 actually for this. We kind of want it to be 10 based on, well, we want these actually to be the same based on what we're going to do in a second here. So I'm just going to input the same number slider into my U and V count. So at least I can adjust that if I want to, but it's going to adjust them to the same number of divisions. Okay, so I have my isotrim, and now I have my is my list of surfaces, right? This is again these are now 100 subsurfaces, each one with their own face and their own edges and their own vertices, respective of their surface. Okay, so to get the edges, I want to do deconstruct brep. Okay, surface brep, and here I'll be able to get the edges. Okay. And then I also need, I'm going to want to grab, I'm going to use the faces actually to grab the center point. So I'm also going to grab an area capsule, area, and input my face geometry into the area capsule to get the centroids. Okay, because we need the grid, but we want to create a new grid from these center points. So the centroid will allow us to do that. We also want to do So we need to do a move command in order to move these off of the original surface, right? So the space frame needs space. So we're going to do move. Okay, and we need to move the centroid, so that geometry. And whoa, it moves quite a lot because the default is 10, yeah. So I'm going to give it a Z motion. And okay, so my factor here is default of 1, which is a little bit better, but I think I still want to have some control over that. So I'm going to input 1.5. Okay, so with that selected, now we can kind of see that there is a series of points that are now up in space that we can start to think of as a new grid, right? So we had our below grid made of these rectangles, but now these kind of start to appear like a new grid where we have new quadrants that we can make. Okay, so so one way we're going to do this, there's multiple ways, of course, to do just about anything in Grasshopper, but the way that we're going to do it is we are going to use this list of points. So I'm going to bring down a panel and we're going to take a look. Okay, we have all these points and they're all separate. So oh, and I'm running into my script. Hold on, let me select this. We'll shift this down. Okay, so one way we're going to do this is we're actually going to yeah, I'm going to flatten my list. That's what I did before. I had to flatten it so that these were all a series of 1 point. So I'm going to flatten my centroid, and you can see how what that just did. So I don't think we've gone over flatten before, but the list that is coming out of this move geometry, this is essentially the same thing. It's just shifted, 1.5 degrees or 1.5 feet in the Z direction. But this list, and if I flatten this list, you can see that all of a sudden my each of my 0 line items has become one singular list, so that all of my points, all my center points, right, they all exist in one list together. If I go back, so I'm right clicking and choosing that. If I go back and I unclick that, you'll see that the original list was, each one of these was a separate list. So it's a list of lists at this point, at this moment, right? Because each one of these is separate, with the 0 line item being its own list item. So by flattening it, it creates one list with each of these as a line item, collecting them all together. Okay, and that becomes important understanding what sort of how this data is organized so that they all talk to each other. So sometimes you'll need to just actually bring down a panel is the best way to do it. Bring down a panel and just take a look at what the output data is so that you can relate that output data to other data that you're trying to create a relationship with, right? So if they don't speak the same language, then they're not going to understand each other. So you have to make sure that they at least are speaking the same, list of a flattened list or a grafted list with the same number of lists in that list. Yeah, it's a good thing I can, I don't know, I can say list well, keep saying it over and over again. Okay, so right, so the way that I did this here was once I created a list, a flattened list here, you can see that it's the same exact thing. Once I created a flattened list, what I did was I have 2 options for how to deal with that list. So with a flattened list, it's now collected all of these center points and they're all together. But what I actually want is to organize them into a new list of lists. So I want to organize them in the count of each one of these divisions that I've done before. Okay, so I remember I had 10 divisions in this direction and 10 divisions in that direction. Knowing that helps me to partition the list into a line of a line of vertices, so that I can create a new grid from those. Okay, so I have two options, right? I said I have there's one that's path mapper and the other one is partition list. They both can do the exact same thing, and I have these here as examples. You can see that the list that is output is exactly the same. So this is a list of 10 points, center points, okay? And this is a list of 10 center points. So the function, whatever's happening inside of here, is the same. It's just a matter of how we're inputting the data, you know. So first, let's do the partition list. So and this is, I don't know if I've made it clear, but the reason we need these, we need to partition the list is that we need to actually create lines to create our new grid. Okay, so what we're trying to do, our goal is to create a line across this, right? We want a new grid, so we want new lines this way, and we want new lines to follow this way. And we're going to do, we're going to use polylines to achieve that, but we need this data organized into those lines first. So I'm going to bring down a partition list. Okay. And the list we're going to partition then is this guy, this move data, or the move geometry. And the size is going to be the length of the divisions, or the number of divisions. So it's going to be this 10, and that's going to go into our partition list. And if I copy and paste this, then I can see that what that's done for me. Okay, so this is the exact same number of points. It's just now organized it into chunks. So I have 10 points and 10 points and 10 points and 10 points, and each one of these is a new branch. So that's going to then organize the polyline that I'm going to do, or I'm going to draw. It's going to organize them through those points. Okay. So I'm going to grab polyline. Okay. And this is going to be my list of vertices. Okay. And if I select that, you can see that it has organized them so that the vertices are working. I think it's in the Y direction, looks like. Yeah. Okay. So there's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and that list is then repeated again here. So there's another list for this one, another list for this one, another list for this. For each line, there's a new list. So they're working for us in the Y direction, but we need them to actually also work in this X-ish direction, right? So we need them to be perpendicular to each other. So I'm going to copy and paste my polyline, but instead of having to try to rearrange this list somehow using my partition, I can just double click and I can choose flip matrix. Okay, and what flip matrix does for me is it reorients the list of these data, the list of these points, so that they're now being organized in this new direction. Okay, so it's taking the center points, and instead of organizing them in this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, it's now flipped that, and it said, nope, now this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and so if I select both of these, you can see I actually have what is now a new grid on top of my old grid. If I look at here, you can see that in space. Okay, So that's great. That's what we want. Um, we want those as our new rectangles. Okay, so I'm going to merge these together so that they're my new grid, and then I think I need to kind of zoom out here and grab. I actually wanted to also grab the bottom grid as well for my space frame. So I have to go back to my deconstruct BREP. I'm going to grab those edges that we wanted and bring those over. Okay. So that I can see now that I have both grids selected. Okay. So with that, now what I need to do is my grasshopper's taking up all my space. If I look at what I want, the whole point of a space frame is that you have these two grids, this one about the center point and this other one as your main structure, your surface structure. I need to connect this center point to these 4 points so that this has some sort of structural support, right? So I need to grab my list of vertices and I need to create lines between this point and these 4 points. So to do that, it would help to have this list of 4 points. Well, as I learned in doing this, I thought, oh no, I'm just going to do a list item and I'll grab my vertices that way. But if I do list item and I take a look at that, okay, what that does for me, it actually separates my list. So I'm going to pull my panel down and take a look. It separates the list into a series of lists, right? And I have to change my output so that it's 0.1, 2, 3, and so this is 0.0. This is going to be 0.1. This is going to be 0.2. This is going to be 0.3. But they're all separate. I don't want that. I want a list of these center points, and I want to quickly. I don't want to have to create 4 different line capsules. I want them to connect to this center point and then a list of these 4 points. So if I look at the output from my deconstruct BREP, I'll notice that it's already done for me. I don't have to do anything. This is already dividing these surfaces so that it outputs for me a list of 1, 2, 3, 4, all 4 points in the same list. Which means what I need to look at what my moved center point is, right? So if I look at my moved center point, this is where our lists need to talk to each other. So as I said, this is a list of lists and this is a flattened list. So that means that if I were to try to do a line, okay, my start point, end point line between my center point list and my quadrant or my subsurface list of vertices. We'll just do that and we'll see. I'm going to save this before I do it because it's going to go crazy. Okay, yeah. Waha! Yikes. You can see that it is not responding the way that I want it to respond. And that is because if I look at this, if I look at the list here and I start to think about the interaction, like the relationship between this list and this list, because those are the two that are talking, right? These are our 4 points. These are our center points. Each one of these points, right? So each one of our center points is trying to attach to each one of these lists. Okay, so they're each one of these list of points. So it's chaos because it's trying to do them all at the same time. So what I need them to do is I need them to talk to each other, and I can do that by unflattening this. Ironically, the thing is if we do that, then we lose our partition and everything we've done later on. So I am going to bring out another geometry container, or even point container would work because these are all points. But I'm going to input that, and then I'm going to right click and choose graphed. So I'm going to control that flattened list. I'm going to pretty much reverse what I've done and create a new list of lists. Okay, and then now that should, yeah, that should be happy with me. Okay, so you can see that now it's connecting this one list of one center point to my list of 4 points, right? So each one of these is maintaining its relationship. It's not trying to connect all of those center points to my list of 4 points. So, okay, so that is the curve that I want. I can probably move those or get rid of them, but I'm going to bring this over here. The wires are all crazy. Should probably bring him below, right? So that he's okay, a little bit better. I probably can turn off my panels since we're done talking about them. Okay. I might rename this too as moved center point, I guess. Move CP. Okay. And then this guy is going to enter my merge. So that when I select my merge, my whole space frame shows up. Right? And my space frame is really a combination of 2 rectangular based grids and all those diagonal supports. Okay. All right, so I think, oh, you know what? I was going to talk about, yeah, we have time. So this was option 1. I was going to talk about the other option for partitioning a list. So up here, I had that as option B. Option A is Path Mapper. And Path Mapper is a kind of simple coding. I guess you can make a simple relationship between a source input and an output. So for our purposes, like we're taking our source as our list, our main list of points, right? Our flattened list, and that is A. That's our major list, and we're translating it to a new sublist, which is I, and I has 10 divisions. So we can write that by typing in, we type in A as our main list, okay? And then we can do I as the intended list, or the list that we intend to create. And then our target list is going to be I, and then this is backslash 10, okay? And I think I almost don't need a space there, I forget. Okay. But what that does then is it takes our major list and it partitions it in the same way that partition list does. So it creates these new chunks for us. It has the exact same input as the vertices list. The only difference is so far as parametricism goes, I have to double click. I have to actually manually input my target, right? So I'm saying that my target is a division of 10. And if I were to update this divisions, so if I were to go back to my script and I were to say, I want my divide domain to be something other than 10, I would just have to know that I have to update that, okay? Versus partition, you have the size of your partition, and that can be a live feed from the same number slider. Okay, so it's just another way to do the same thing. Okay. All right. So now that we have our our lines, our curve network, we can pipe it. So if I double click and I type in pipe, okay, and we can put in our curves to our pipe and watch them explode because the radius is set to 1, I think. Yeah. Wee. It's like a floating mattress or something. I'm going to do like 0.7, okay, as the radius. Okay, even that's a little fat. You can see it's a little thick for what it is. I mean, it's a space frame, so it doesn't need to be quite that intense. It could probably be 0.5, 0.6. Okay. And now so this would probably be what we're going to bake, right? So I would group that, probably change the blob and the output color, give it a bake me, and then go back into the front part of my script and look at what surface I have and start to try to think about, is this the space frame I want? Is this the form? Because for our input, we have these curves that it's feeding from RhinoSpace, right? So if I update this curve, I can actually it'll live update my whole space frame, right? I can adjust this. Probably don't want to get it too wild, but I could sit and I could figure out then what exactly, what surface I want it to follow, which is why I have this other surface drawn, which is this guy. Okay, so I'm gonna move him over since he's a little in the way. So what I did, actually turn these off, bring him over. So this is just another way to go about creating the form for your space frame or your grid or whatever you're going to create using your surface. You can create that surface in Grasshopper space, of course, too. But if you want to just reference geometry in Rhino ever and then use that as your reference, this is a good thing to note. So for this one, I just drew a series of parabolas. So I went to, I always have to find this because I have to think about it. Yeah, I go to my, what looks like an interpolated curve, right, my control point curve. And I went to parabola from 3 points. Then I went into my front view and I drew a parabola, okay? And then it needs some direction, right? Rectilinear. If I hold shift, it'll stay straight. So you can adjust it as you want, but I created a parabola and then I moved my parabola over in space. That didn't work. Alt. Okay, so I had both on the same end, and then I shifted, I made another one, generally in the middle. Then I went back to my front view and I adjusted these control points so that it was a little smaller. Okay. This is where Gumball is quite nice if you're just estimating geometry. Oh, except for if you choose the wrong one. Goodness. Okay, let's try it again. Right, I was trying to make a smaller central section. Okay, kind of like the one in here, right? It has the curvy form. It doesn't have to be parabolas, of course, it can be whatever. But then I loft and I had my style set to normal so that it follows this rather simply, right? It's not, if you do straight sections, depends on what your input's set to. So you want to make sure it's set to something a little more loose. So then I got my surface, and then in Grasshopper space, I created a new surface capsule. And I right click and I said set one surface. Okay, I just select it, automatically updates because I did set one. And then what I did was and this is probably a good rule of thumb, is to disconnect rather than replace for a something at the beginning of your script. And I mean that, like, if you have too much information being fed from your origin geometry, if you replace it too quickly, it can kind of gum things up and get a little slow. So if you just disconnect it, the rest of these will go orange for a few seconds, but then, you know, it should be relatively quick to update in comparison to direct input and replacement. Okay, so you can see here what it's done is it's tried its best to estimate a space frame based on our initial geometry. Now, to note, the way that we've modeled this isn't exactly the way that you'd want to model a space frame if you're going to really have it as a structure, and that's because if you look at this, if you take a look at what's happening to our nodes, right, to our center points, all of this whole rectangular thing that we made is moving only up, right? It's only moving in the z-axis, so you're getting this really weird like shape on the edges, as well as like just location of the second grid. So really what we'd want to do, a way to correct this, is to change our vector. So the vector that we used from the center point to the new center point, we just made it z. What you'd want to do is you'd want to somehow find the vector that is orienting perpendicular to the surface, and that's how you'd correct it. But honestly, it's a little bit of we'd have to do some gymnastics right now, so I'm just going to say that's how you would solve it if you want to do this. You're more than welcome to go down that route, but that would be how you'd have to do it. You have to create a 2-point vector and create that as perpendicular to each of these surfaces, which is totally doable because you have the center point already. You just need to find a plane. You need to construct a plane on each and every one of these and find what that orientation is perpendicular to that center point. And then just create a 2-point vector, and that's that's it. So so this is another way of doing it, is by inputting your surface into the geometry, or by going up here and creating your own free-form surface in Grasshopper and approaching the problem that way. Okay, so I think that was pretty much all I wanted to go over in Grasshopper space. We still have like 10 minutes left, and I really wanted to kind of walk through the process after Grasshopper. So I know we talked about Rhino space last time and imaging and stuff, but I also wanted to kind of go through a little bit of a layout, like bringing that stuff into a layout. So bear with me if some of the stuff is redundant, I guess, or you know, whatever. But it's just, I think, maybe some helpful tips for if some of this is new to you. Okay, so I'm going to input that. I actually did want well, no, this is fine. We'll just bake this and let it be. Okay, so I'm going to create a new layer here, and I'm going to call it D for my space frame. Obviously, I've been doing this a bit. Also going to delete those, it's not important. And then in my Grasshopper, I'm going to bake this piped structure and place it on the space frame layer. So I went to right click for my output, and then bake, selected my layer, group, okay. I'll give it a second because it's going to have to, there's a bit to think about. I'm going to turn off my Grasshopper so I don't have that as confusing me or cluttering up my screen. I'm also going to turn off my surface and take a look at what I've made. Okay. So what I have set up is a series of views for myself, and I think it's a good way to to just have to practice. Like you should probably also always set up a named view if you're going to reuse a particular view, or if you're going to re-render something. They will save you a lot of time and energy because, yeah, if you have to re-render an image and it takes a long time to render it, if you move your screen at all, then you don't have a saved view, you will have to find that exact relationship, and that is almost impossible. So you're most definitely, like if you have post-processing set up, like a Photoshop file or something on the other end with those saved relationships, you're going to be wasting a lot of time. And how do I know that? So if I go to my my window here and I go to my display settings, I have my Arctic set up already for me, and I have my materials set to white. You don't have to do a black background. I just have it set up this way because I wanted to kind of talk about different ways of approaching your the export of your model, especially if it doesn't have materiality, even though some of yours does, and that's great. You don't have to worry about white on white as much. But like last week, I showed you like the line weight settings so that you could kind of start to control the white on white relationship. This is another way, of course, it's just changing the background or changing the materiality of the object itself. Okay, so for here, what I would do is I would set up my shape, and then I would save this as something. So I think I actually have already, I think I moved this in space. So let me turn on A, B, it was B, okay. All right, I forget. All right, so this is B, yeah. Okay, so what I had was I had my layer set up, so I had B set up with a named view called B1, B2, and B3. And each one of those was like a preset, ooh, that was a little off, but a preset view that I could then just replace that geometry ideally. And as I model it and as I iterate it, I can turn off that layer. So I could turn off B and turn on C or something if it's in the same spot, and then export it really quickly. So for instance, for here, if I'm going to do a view capture to file, capture the file this way. If you do the underscore, the little window will come up. Should come up. Give it a second. If you don't do the underscore, you'll get the ribbon options. Okay, there we go. So, right, I get my view capture settings. We've already gone through this. You have these options. So say I have a transparent background as one setting. If I don't have that, notice it's going to update and it's going to show me it's going to output as all black as my background. Okay, so I'm going to choose transparent background as 1, and then I'll save that as a PNG. So I actually already have it saved here, so I'm not going to do it again. I'm just showing you the process. I'm going to do view capture file again and show you the other way of having the background already set up. Okay, so I do OK, and then I can save it as a JPEG, and then my JPEG will be the same exact image, but it's going to have a black background for me. Okay, so if I go into my InDesign space then, and I have my images already set up. Okay, so notice, and I know you've probably used InDesign a lot and are probably familiar with it. If you're not, this is just a brief overview of how to kind of interact with InDesign, and also, you know, if you do use InDesign in your work ever, in a paid job, like, you know, later in life in your career, you're going to probably be sharing that file with your coworkers. So it's beneficial to you and them to have good organization and understanding of what layers are where, and yeah, just general approach. So the way I usually do it is I have 4 base layers, and this is my approach. So everybody does it a little different, but these are generally also what layers you'll see in other InDesign layouts as well. Okay, maybe not exactly, but you'll generally these are the base ones. One will be a background, something that is a locked layer that is just the general template, which can be controlled with pages, of course, but you can also just place a new background on each slide if you want to do different ones. But if you lock it, then it stays there. So for instance, my black is my background, and because it's locked right now, I can't touch it. If I unlock it, now I can select it and I can move it, okay, or I can adjust it, okay. So I'm going to keep that locked. I'm going to turn it off right now so you can kind of see the way I have it set up. Control plus is to move in. And if I take a look, then I can see that I've got 4 images that I've placed. And as a normal view, right? So if I look over here and I have my view settings, if I have my normal view up, it kind of looks like a cluster, right? It just doesn't really make sense. But if I turn on my preview and I turn on my background, then things kind of start to take place on the screen. And now this is not the greatest layout ever. I'm just noting that. I'm just showing you a way to approach general file management and organization, and think about the way you approach your layout. Okay, so I'm going to turn off my background. So I have my images all on their own layer, so that when I want to, I can turn that off and on. And then I have my graphics. My graphics are like this. This little guy, like these. I have like a extension lines in between my pieces. So those are on their own layer, so that if I want to just select them, I can lock all of my other layers and then just quickly select the tiny little lines that I want to select. Okay, it's very helpful to have, good layer management again. It's kind of true for everything. And then lastly, of course, is your text layer. So you want to have your text on your own separate layers so that you can go through and just kind of quickly select it, quickly adjust it, and then move on with your projects. Okay, so I'm going to go back to preview. I think the other thing to note is the borders, the margins. Generally, you want to make sure that you hold the edge. You want to hold a border. If you don't hold a border, or if you don't have a margin, you want to bleed across the edge. You don't want to have, you do not want something where the, let's see, I messed up myself by making my text white, because then I can't really quickly adjust. Okay, right, but I would want to fully bleed to the edge versus something where my image barely goes to the edge of the page, right? If it's, and even that could be a border if I hold it, but it cannot be disorderly, such as one side is different from the other. You want to be consistent with your image, and whenever I talk about this stuff, I always feel so nitpicky. Like I feel like some grammar school lady, but it's like in our profession, it matters quite a lot, because we're paid for our understanding of like display and graphic. So if you ignore those things, you're probably your work is going to it's just not going to be as professional. People are, if they see a misspelling or they see something that's kind of like an error or something wrong, immediately their opinion goes, their trust in you as a designer kind of goes away. So you want to make sure that you comb through your example. You're showing your example, sorry, I'm reading the screen. You want to comb through your work, and you want to make sure that you have these tiny little nitpicky things already down. Your T's are crossed, your I's are dotted, and you don't have to worry about that. What they're going to worry about is your pretty stuff that you've made up. Okay, So that's the other thing is like text is really important. So you don't, if your text is like off center or like, you know, like if I put it up here, this just looks wrong. It looks like the page was cropped, right? It looks like there's no edge being held. It looks like a mistake. So you at least want to have some sort of buffer between the edge of the page and your text. It doesn't really matter how much, but I would usually, like I usually hold it way over here. I make it really stupid and plain. You know, I'm like, there's probably no fun in it, but it's just like, at least it's holding the margin that I have, right? So, and you can play with that, but that's just one of the things I sometimes see is the text is like all over, and it's like, you know, just control it and keep it simple. We don't need a novel, and we also don't want to see Times New Roman. So that's the other thing is your font. For instance, I have Century Gothic, but I forget what the is it Times New Roman is the default. I never even use it. Oh, Minion Pro. Okay. All right. So let's take a look at the difference between this font and say a sans serif font. And look at that, I spelled blah wrong. Okay. So if we take a look at these two fonts, you'll see that this one, if we look at it, I don't know if you guys have, if anyone's told you this, so I'm just going to tell you that there's a difference between what is called a serifed font and a sans serif font. And sans serif font is something that has no extra curlicues. There's no extra what is called serifed. You can see here there's a kind of dab where the pen would go down, and then the letter or number whatever would be created. Whereas here it's very computer based, right? It'd be hard to write this with a pen, but in a computer it's like very clean and there's no extra. So it's kind of a modern font. You want to, if you're going to use a serifed font, you want to be cognizant that you're using it. So you can use it, but I think that quite typically these are more for like the written word. So something like a magazine or a book, something where the words are more important than the graphic. That's when a serifed font would be used, versus a design book. You would use these only with some clear intent. So you would, like if it's supposed to be something maybe more literary in design, or like you have some purpose for using it. The thing is you want to understand that you're using it and know that it has some sort of like effect. So I think, because this is a practice, like I think of this as a practice class for your studio, like I would say try out different fonts and see what works for you. Like see what fits you, because fonts also have like a certain character to them. Same with the color. Like you might not want an all black background, and I totally get that. I actually don't really like it either, but it does strike it. It's striking, and it really allows the object to pop off the page. So there is that. There are definitely limitations, because right now shading is kind of null. You'd almost have to do like some sort of white shading or whatever. We don't have a surface that's even on. So there's a lot of things that are missing. But anyways, so that's just something to note while you're doing your assignments, that is nitpicky and small as it is, and I've already gone like 5 minutes about this, but as small as it is, it does say something about the project, and that's I can't even help that. It's just true. So just know that for your studio, and you should be good. It's also kind of fun. I don't know, maybe I'm nerdy, but I also like to play with the font, like color and size and layout, and how each one kind of says something different about each project. For instance, I had a coworker, yeah, no, classmate. He really loved Bank Gothic, and I found it so like blocky. Um, but for him, it worked, and um, his style of design fit it, so it worked on the page for him. Versus if I were to use it, it wouldn't look right because my projects were a little too soft. So you just want to like kind of think about what you're using and see whether or not it works for you. Okay, so enough about that. Are there let's see, anything else? Maybe it's good to talk about links too. I don't know if you guys have played with InDesign and how much, but links are important to understand that when you're bringing in an object here. So if I have a text box and my layers, of course, locked. If I have a image box, and I want to bring in a new image, I can go to my links and I can do relink to a new image, okay, and reset that. Or I can select this box and also do Control D, and that will do the same thing, where I can replace the selected box that this image is in. Right? If I double click in there, I can see that this is the image that's actually that is the JPEG or the PNG, and that this blue box is just a view portal to that. Okay, but it's important to like kind of check these and make sure that they're all good. Like you'll probably also get an error, right, if they're not properly linked. But sometimes if you have like a larger board or something, you've been working on the same Photoshop file, and if you have a live Photoshop file linked, you might forget to update that link, right? You have to update if it's old, an old link, you'll have to go in here and you'll have to do update. And that way it will reset whatever image is in here. And I guess that's another thing to talk about is just how InDesign works, right? InDesign is a lighter version of, well, not even a lighter version, it's its own thing. But it's a lighter software in that it doesn't hold information, it doesn't hold data in the file. It's all referenced somewhere else. Like it will hold the text, of course, and it will hold like the black background I've drawn. But these image files are all links. They're all somewhere else. So it makes InDesign files a little bit smaller and lighter and easier to work with. And so as you're working with them, to know that it also depends on your display performance, right? It's usually typical display quality. If you have it at high quality display, you'll see it'll look almost like you're going to print it. However, you're also going to be super slow and dragging. So it depends on the size of the file, but if you have like a large Photoshop file, it's definitely going to lag for you. And that isn't what you want. So you just kind of you can check it, but you want to make sure that that's usually set to typical display. Same thing for all of these. You kind of want to go through and make sure that like these should be set to, it says use view setting, and if it's not, then you're going to want to make sure it's typical display. Okay, and then pages are, oh my God, I'm over, aren't I? It's 4:40 that this class gets. I always think it's 4:50. I think it's because my earlier class stops at 50. Okay, so I've talked 10 minutes extra about InDesign and you guys are so bored. Okay, so I hope that was helpful and that you kind of understand a little bit more that it's not just like this class is, yes, Grasshopper heavy and Rhino heavy, but that it's also about the production of it and getting that information to read well, and then also presenting it well too, because the presentation is also a lot of what you're doing throughout your school and career. So yeah, blah, blah, blah. I get tired of hearing myself. I'm sure you guys are tired of it too. But I hope you learned something, and if you have questions, I'm here after. So if you have something else to do, it's cool. But otherwise, I did record it this week and I will put it online. Yeah. So thank you guys, and I'll see you next week.
Thank you.
Peace. Okay, I'm also going to stop the recording.